Assalamu alaikum. This is your chemistry teacher Sir Naushad Mehdi, and in today's video we're going to solve the IGCSE Feb March 2025 paper 6-2, which is ATP alternative to practical. So let's start. First of all, this is the question number one, and in this question number one, it is related to the topic of the chromatography. You can see the chromatography experiment. The diagram for it is drawn in the question. Now in the part A, it is saying that identify the two errors the student made. Okay, so if you carefully look at this diagram, so you can see the different sample of inks are present over there: yellow, orange, green, blue, purple, and black. But all these samples which are put on this chromatography paper, that are present or they are placed below the baseline, and we all know that on the chromatography paper, whenever we draw the baseline, so the damn sample should be placed in the center and should be above the baseline. But over here you can see all the samples of the ink are not placed on the baseline, they are placed below the baseline. So this is the first error. So first error, we can write that the ink samples are placed below the baseline. Okay. Secondly, you can see there is one more error, that when the chromatography paper is dipped, so this is the solvent. So the chromatography paper should be dipped inside the solvent in such a way that the baseline should be above the solvent. But here you can see in the diagram that the solvent level is below the chromatography paper. The chromatography paper is not being dipped inside. Okay, so the chromatography paper should be a little bit dipped inside in such a way that the baseline should be above the solvent level, but over here the baseline is not being dipped in the chromatography paper is not dipped inside the solvent. Okay, so this is the second error which the student has made. So we can write this point in a way that the solvent, which is water in our case right now, so is the chromatography chromatography paper. Okay, now state the name of the equipment used to draw the baseline on the chromatography paper. As you all know that during the experiment of chromatography, whenever you are drawing this baseline, so this baseline should always be drawn with a pencil. Okay, so pencil would be your equipment through which you would be drawing the baseline, and obviously you want to draw a straight line. So for that straight line you must be needing a ruler also. So these are the two equipments which are required to draw a baseline. Okay, now in the part C, the student corrects the errors and then carries out the chromatography. The chromatogram shows the results. Okay, the student's results. So these are the results which are being shown. So identify an ink which could contain only one colored dye. So you have to check that which sample is made up of only one colored dye. So it means that it should be having only one spot above the baseline. So here you can see the yellow ink. It is only having a one spot. It means that it is only having a one color dye. So we can write yellow. And any other, let's suppose we can take blue as well, because above the blue it's also made up of only one color dye. So yellow and blue both can be the answer for this question, and the rest of the inks are made up of more than one color dye. Okay. Second part, deduce which ink could be mixed with the blue ink to make the black ink. So basically you have to mix any other color ink with the blue ink to make the black ink. So first of all, check the black ink. So when you will check the black ink, so black ink is made up of three different colored dyes. Okay. So in order to make the black ink from the blue ink, okay, so if you check the blue ink, so blue ink is having one of the dye which is already uh, matching, or it is already present in the black ink also. Okay, so blue color is having one color dye which is already present in the black ink. So these are two uh, different color dyes which are also present in the black ink, and you also need them. Okay, if you want to make a black ink from the blue ink, okay, so you have to mix the blue ink with any of the other color ink which should contain these two dyes also. So here you can see, if you take the orange ink, okay, so orange ink is having these two color dyes which are the same as the black ink. Okay, so if you mix the blue ink with the orange ink, okay, when you will mix it together, so all the three dyes, 1, 2 and 3, all these three dyes will be also present in the black ink also. Okay, so blue ink must be mixed with the orange ink. Deduce the color of the one dye that is contained in all the three of orange, green and black inks. Okay, so you have to check which color dye is present in orange, green and blue, sorry, orange, green and black ink. Okay, so we have to select the orange one, green one and the black ink. Okay, so you have to check that one color dye which is present in all three of them. So you can see this one. Okay, this dye is also present in the green dye also, and over here black dye also. So these three colors are being matched which are present in orange, green and black, and this is present in the yellow also. So it means that the yellow ink is present in the orange ink also, it is also present in the green ink also, and it also present in the black ink also. So that one color dye is the yellow ink, which is present in all three of them, orange, green and black. Okay, now moving on to the next question, question number 2. The question number 2 uh, says that a student investigates the temperature change when aqueous copper 2 sulfate reacts completely with two different metals, zinc and iron. So you're reacting aqueous copper 2 sulfate with the zinc and iron. So the student does two experiments. Okay, so the first experiment, he was using 3 grams of iron powder, and in the another experiment he was using the 3 grams of zinc powder. And these are the steps. Okay, first of all he took a 50 centimeter cube measuring cylinder. Okay, and in that measuring cylinder he poured down 30 centimeter cube of copper 2 sulfate into it. uh, then he used a thermometer to measure the temperature, initial temperature. Okay, and that time, the time is 0 seconds, and then he add 3 grams of zinc powder into the beaker, and then he start the stopwatch, and then by using the thermometer after every 30 seconds, he is recording the temperature. Okay, so here is the table given for this question. So you have to complete this table by looking at all these readings from the thermometer. Okay, so the initial temperature, first of all, just look at the initial temperature. The initial temperature was okay, temperature change since the time 0 is 0. Okay, so the initial temperature is 24 degrees centigrade at which this reaction has been started. So you have to record down the temperatures. So after 30 seconds, this is the temperature reading given to you. So if you look at carefully over here, it's 31, 32, 33 and 34. So this point is coming in between 33 and 34. So it means that it would be 33.5. Okay. Similarly, the next one would be it's around over here 38. Okay, the next one it would be it's 41 over here and 42. So this is in between the 40 and 41. Okay, so it comes around to be uh, almost 40.5. Okay, the next one is 41, 42 and 43. Okay, the next one, if we look at this one, it comes around 41, 42, 43, and this one 44. All right. Then we have uh, 41, 42, and 43 again. And the last one is around 41. Okay. Similarly, for the experiment number 2, we can jot down the readings also. Over here we have this around 24. This one is in between the 25 and 26. So it would be 25.5. Okay, this one it would be around 25, 26, and 27. Okay, this one is around 28. Okay, this one is 28, in between the 28 and 29, so it's 28.5. Then we have this one as 29, and okay, so last one is again here we can see that it's 29. Now we need to find out the difference in the temperature also. At time 0, the initial temperature is 24 degrees centigrade, so we need to find out the change in temperatures also. So the first one would be 33.5 minus 24, so it comes out to be 9.5. Okay, similarly 38 minus 24, 14, 24, it becomes around 17.5. Then we have 43 minus 24, it becomes around 19. Then we have 44 minus 24 equals to 20. 43 minus 24 becomes 19 again. 41 minus 24 it becomes 17. Okay, so over here the initial temperature is 22 at the time 0. So 24 minus 22 it becomes 2. 25.5 minus 22 is 3.5. 27 minus 25 it becomes 2. Okay, sorry, it's 27 minus 22 it becomes 5, and we have then 28 minus 22 6. 28.5 minus 22 6.5, and we have 29 minus 22 7, and 29 minus 22 7. So in this way we have completed this table for 4 marks. Now we have to draw the graph. Okay, so draw the two curves of the best fit, and both the curves that start at 0 0. Okay, so you have to draw both the experiment number 1 and experiment number 2. So on x-axis we have time, and on the y-axis we have the temperature change. So we have to plot the temperature change for both the experiments with respect to the time. Okay, so here we can see the temperature change starts from 0, and the maximum value of the temperature change is around almost the highest value of the temperature change is around almost 20. Okay, so it means that we have to draw the scale over here. So since the highest value is around 20, so we can take every 10 boxes for the 5. Okay, so here we can take uh, 5 over here, 10, 15, 20, and then 25. So first of all we have to plot the experiment number 1. So in experiment number 1 at time 0 we have 0, so it's already there, it's already drawn over there. At time 0 it's already 0. And then we have time 30 seconds 9.5. So at 30 seconds, so here you can see 0 and 50, we have 10 boxes over there. Okay, so each small box is representing the 5 over here, so we have to go up to 30. So 5, 10, 15, 20, 25, 30. So at 30 the value is 9.5. So 9.5 comes somewhere around over here. Okay, and then we have at 60 we have 14. At 90 we have 17.5. 90 we have 17.5. So here we have this 16, 17.5. Okay, then we have 120, 19. At 120 we have 19. Yes, somewhere here. At 150 we have 20. Over here, and then we have 180, 19. Then we have 19, and then 210 we have 17. So 18, 17, 17 is over here. Okay, so these are the points we have plotted for the experiment number 1, and it is saying that we have to start from 0 0 curve, and we have to draw a best fit line for it. Okay, so start drawing the line. So this is for the experiment number 1. Experiment number 1. Now similarly you have to draw it for the experiment number 2 also. So at 22 it starts from 0, and then we have at 30 we have 2 degree. 30 we have 2. Okay, and then we have 3.5. 3.5. 1, 2, 3. So here we have 3.5. Then we have 5. Right? Then we have 126. Then we have at 150 6.5. Then we have at 187. And then we have 7 again at 210. So this is the graph for the experiment number 2. This is for the experiment number 2. Okay. Now, now in the question they are saying K extrapolate the curve for the experiment number 1 on the graph to deduce the temperature in the experiment number 1 after 240 seconds. So you have to extrapolate the graph. You have to extend the graph for the experiment number 1 for about 240 seconds. So here is the curve, so we can extrapolate. So if you take out the reading at around 240, so it's coming out to be almost, okay, so it's coming out to be almost around 14 or 14.5. So here the temperature change would be 14.5 degrees centigrade. Okay, state which experiment number 1 or experiment number 2 is more exothermic and explain your answer. So here you can see that experiment number 1, if we look at both the graphs, so in the experiment number 1 we have a large temperature change. Okay, we have a huge temperature change. It means that it has released more amount of energy. So it would be more exothermic. Okay, so it's very simple. Experiment number 1. And what is the reason? Because more, or we can say there is a greater temperature change due to more release of heat energy. Okay, alright. Now predict the temperature change of the solution in the experiment number 1 after 3 hours. So they are asking us to predict the temperature change after 3 hours. Okay, so initially the temperature was finally the experiment was at about almost at 210 minutes, sorry, seconds, 210 seconds. Okay, so after 3 hours means that it is a very long time. So after a very long time, obviously the reaction has been stopped, and after a very long time what will happen? The reaction will again come back to its original state at its original initial temperature, because all the heat which is being released in the surrounding, that all the temperature change is now being constant, and the reaction has been stopped because this is a too much time. So after this time the reaction has been stopped. Okay, so obviously after 3 hours the temperature will come again to its normal state or the initial state. And what was the initial temperature? It was 24 degrees centigrade. So answer would be 24 degrees centigrade. Okay, explain why using a copper container instead of a beaker would not be an improvement in this investigation. So they are saying that if they use a copper container instead of a beaker, so that wouldn't be any improvement. Why? Because as we all know that the copper is a metal, and since what we are doing in this experiment, we are measuring the temperature change, that how much heat energy is released during an experiment. So if we want to measure the amount of heat energy, what we are doing, we are measuring the temperature change. Okay, but what we are doing this experiment in a glass beaker, and as we all know that the glass beaker is not a good insulator. Okay, and what will happen, the heat which is being produced during the experiment, it will be released out, it will be lost into the surrounding. And if the heat energy is lost into the surrounding, it means that your experiment would be having an errors, right? So what they are saying that if they replace this glass with the copper, then again it is of no use, it is not an improvement. Why? Because as we all know that copper is also a good conductor of electricity. Okay, and if you will use the copper instead of glass, then again the heat loss will be there. Okay, so it is of no use to replace the glass with the copper, you will be having the same problem of the heat loss. Okay, so copper is a good conductor of heat, therefore it will also not prevent the heat loss, also not prevent the heat loss. Okay, describe the two changes in the apparatus that will improve the results of this investigation. For each change, explain why it will improve the results. Okay, so one of the change, as we already know that, okay, since they are using the glass beaker, and because of that glass beaker, what is happening? The heat is lost into the surrounding. Okay, so instead of using a glass beaker, they should use a certain that container which is an insulator. And for that, what they can do? They can do the experiment by using the polystyrene cup. Okay, instead of taking the glass beaker, they can do the experiment in the polystyrene cup. Okay, so we can write that use a polystyrene cup with a lid also for insulation. Okay, so and we also have to give the explanation for that, okay, why we are using this. So it's very simple that polystyrene is an insulator. Polystyrene is an insulator which will prevent the heat loss. Which will prevent heat loss. Okay. Secondly, what change we can do in this experiment if we go upward. Okay. And if we read out this procedure. So in this procedure, what they are doing, they are using a 50 centimeter cube measuring cylinder to pour 30 centimeter cube of copper sulfate into a beaker. So what they are doing, they are using a measuring cylinder for transferring or for pouring down the copper sulfate into the beaker. Okay, so instead of using a measuring cylinder, we can use a burette also. Okay, because the burette is more accurate than the measuring cylinder. Okay, so instead of using the measuring cylinder, we can use a burette also to take the accurate readings. So here we can write change number 2. Okay, we can use a burette uh, instead of measuring cylinder. Okay, and why we are using? Because uh, more accurate volume measurement, for more accurate volume measurement by a burette. Okay, all right. Now in this question number 3, this question is related to the topic of the qualitative analysis, and it says that, okay, we have two solutions. We have two substances. One is the solution A and the solid B. These are the tests on the solid solution A. So he is saying that the solution A is chromium 3 chloride, which is CrCl3. Okay, because chromium 3 means Cr plus 3 and chloride is equal to 7 minus 1. So if you cross multiply, you will get CrCl3. The student divides the solution A into three approximately equal portions. Okay, to the first portion of the solution A, the student adds the aqueous sodium hydroxide dropwise until it is in excess. So as we all know that we have to go to the table which is already given at the back of this paper of the qualitative analysis. So they are adding the aqueous sodium hydroxide dropwise. So we are adding the aqueous sodium hydroxide dropwise. So in our salt, what was the cation? The cation was the chromium Cr plus 3. So chromium Cr plus 3 gives you a green precipitate which is soluble in axis. Okay, so here we can write green PPT, uh, green PPT formed, which is soluble in axis, forming a green solution. Okay. The part B, it is saying that the second portion of the solution A, the student adds about 1 centimeter cube of dilute nitric acid, followed by the few drops of aqueous barium nitrate. Okay, so we are adding the dilute nitric acid followed by a few drops of aqueous barium nitrate. So here you can see dilute nitric acid up and then aqueous barium nitrate. So this test is used to identify the sulfate ion. So is the sulfate ion present in our solution? No. Okay, so since sulfate ion is not present, so this test will give no change. Okay, nothing will be happen because the sulfate ion is not present. To the third portion of the solution A, the student adds 1 centimeter cube of dilute nitric acid followed by few drops of aqueous silver nitrate. So dilute nitric acid followed by aqueous silver nitrate. So this test is used to identify the halogens or the halide ions. So in our case, the chloride ion is present. Okay, you can see in the question it was CrCl3. So since the chloride ion is present, so what will happen? What would be the result? The white PPT will be formed. So here we can write K observation, K white PPT will be formed. Okay, now these are the tests on the solid B. So in the solid B, first of all, it is saying that he has carried out a flame test, and this flame test is producing the red color flame. So go to the table and check that which metal produces the red color flame. So it's the lithium. Okay, so it means that in the solid B, the lithium ion is present, which is giving you a red color flame. Dissolve the remaining solid B in the distilled water to form the solution B. To the first portion of the solution B, adds a few drop of acidified aqueous potassium magnate. Okay, so aqueous potassium magnate when we are adding, so what is the color of aqueous potassium magnate? It's already purple. Okay, you all know that the KMNO4 aqueous potassium magnate is of the purple color. Okay, and what happens? The purple color remains and the pale purple solution forms. It means that there is no color change. The color of the potassium magnate remains as it is. Okay, so when you go back to the table, so here you can see for the sulfite ion, it's written that when you are adding the acidified potassium magnate, so the purple color changes to colorless, but over here the purple color is remaining purple, it is not changing. Okay, so since there is no change, it means that the sulfite ion is not present, because sulfite ion would be changing the color from purple to colorless, but it's remaining purple over here, so it means that no sulfite ion present. Okay, to the second portion of the solution B, add about 1 centimeter cube of aqueous sodium hydroxide. Okay, so you are adding the aqueous sodium hydroxide, so the solution remains colorless. So solution remains colorless, it means that no change is taking place over here. Okay, similarly what we are doing, we are continuing this test 3 in the test 4. Warm the products of the test 3 and test any gas given off with the damp red litmus paper. Okay, so here what they are saying, that the damp red litmus paper remains red. It means that again the no change is taking place over here. Okay, whatever the products, basically what we are doing in the test 3, when we added the sodium hydroxide and then we are heating it. So when we are heating it or when we are warming it, so a certain gas will be produced, but that gas is not changing the red litmus paper. Okay, it remains unchanged. And in the test number 5, what it is saying, to the third portion of the solution B, add 1 centimeter cube of the nitric acid followed by the few drops of aqueous barium nitrate. So white PPT is formed. Okay, so 1 centimeter cube of nitric acid followed by aqueous barium nitrate. So here you can see, okay, this is the test of nitric acid followed by barium nitrate. So white PPT is formed. That is what it's also given in the question. So it means that the sulfate ion would be present. Okay, so we can make conclusion over here. Okay, sulfate ion is present. All right. So describe how to carry out the flame test in the test number one. So they are asking you the procedure for the flame test, and it's very simple. And for the flame test, what we have to do, first of all, we have to take uh, a platinum wire, a clean platinum wire, okay, and that platinum wire should be take a clean platinum wire, and secondly, what we have to do, dip it inside, dip it in concentrated HCl, okay, so dipped in concentrated HCl, and after dipping it in the concentrated HCl, okay, what you have to do, dip it, uh, now dip it in the paste. We have to take the paste of the salt, okay, so dip it in the paste of the solid B, and then heat it, uh, heat it in the flame, heat it in the flame to observe the color change. Okay, so basically what we are doing, we are taking the platinum wire, okay, we are dipping that platinum wire in the concentrated HCl, and then we are dipping that platinum wire in the paste. Basically we have made the paste of the solid substance with the help of the HCl, so we have to dip that platinum wire in the paste, okay, and then after dipping it, we have to take that little bit paste which would be stuck in a on the platinum wire. You have to take it near to the flame. So as soon as you will take it in the flame, so the color of the flame will gonna change, and you have to record that color, okay, so that how the flame test is being carried out. So identify, okay, the next question, identify the ion that is tested in the test number 4. So in the test number 4, what we are doing, we were heating, after adding the sodium hydroxide, we were heating the remaining mixture, and we were testing it for the gas which is being given off with a damp red litmus paper. So if we go back to the table, and in the table if we look at the test which is for the damp red litmus paper, so we can find it out that this test goes for this ammonium ion, okay, all right. So when ammonium ion is present, ammonium ion is present in any of the solids, so what happens after heating it, after when you add the sodium hydroxide, and after adding sodium hydroxide, when you are warming it, okay, so the ammonia gas is produced. That is what we are doing over here also, okay. What we did, we add the sodium hydroxide in the test number 3. After adding sodium hydroxide, we were warming it. So after warming it, if the ammonia gas is produced over here, if the ammonia gas is produced, so what ammonia gas will do? Go to the table of the gases. Ammonia gas will turn the red litmus paper blue. Okay. So is the damp litmus paper becoming blue in our case? No. In our case, it is not changing. The damp that litmus paper remains red. So what does it mean? That on the warming, the ammonia gas is not produced. And if the ammonia gas is not produced on warming, it means that the ammonium ion is not present. Okay. So basically, test number 4 was to check that whether the ammonium ion is present or not. Okay. So if the ammonium ion was present, then upon warming, the damp that litmus paper would change to blue color. But over here, it is not happening. So it means that ammonium ion is not present. So I need to find that that is tested. So ammonium ion is being tested. Okay, which is not present in our solid. Identify the two ions which are present in the solid B. So in the solid B, you have to identify the two ions which are present. So when you will analyze all the tests, so lithium ion from the test number 1 is being confirmed, And from test number 5, sulfate ion is being confirmed. So the two ions which you have identified is number one lithium ion and the second one is the sulfate ion. I hope that is clear to everyone. Okay, alright. So now this is the last question, and this last question is the planning question, and you have to plan an experiment according to the scenario which is given in the question. So let's solve it. Metal spoons can be electroplated with silver. Describe how a metal spoon can be electroplated with a silver. So basically this question is from the topic of electroplating. Include in your answer how could you determine the mass of the silver electroplated on the metal spoon. So basically you have to describe the complete experiment and how you will do the electroplating of silver onto the spoon. You are provided with the solid silver nitrate, a metal spoon, a piece of solid silver, distilled water, and a common laboratory apparatus. So first of all, if we look at the diagram, that how the electroplating takes place. So you have studied in your syllabus that okay, whatever object upon which you have to do the plating, that object in our case is the spoon, okay, metal spoon. So that spoon or that object must be taken at the cathode, okay. So at the cathode you have to take an object which over which you have to do the plating. So in our case, metal spoon would be taken at the cathode, and at the anode you have to take that piece of metal by which you have to do the plating. So in our case, we are doing the plating with the help of the silver metal. So silver metal has to be taken on the anode. Now you have to connect it with the battery. Okay, so this is your anode, which is made up of silver. Okay, silver rod. So in the question, we have used this silver, a piece of the silver rod or solid silver. Okay, we have used this metal spoon also. And now this is your anode and this is your cathode. So cathode is negative and anode is positive. So these two, anode and cathode, must be dipped inside some electrolyte. So what would be the electrolyte? Electrolyte is always taken as an aqueous solution of the salt of this anode. Whatever metal is present at the anode, you have to take the salt solution of that salt, of that metal. Okay, for example, right now silver is present. Okay, so what you have to do, you have to take the salt solution of the silver as an electrolyte. So in our question also it's mentioned over there that they are giving you solid silver nitrate, but as you all know that the solid silver nitrate cannot act as an electrolyte because it's solid. Electrolyte can only be either in the aqueous form or in the molten form. So they are giving you the distilled water also. So first of all, by with the help of the distilled water, you will dissolve that silver nitrate, and you will make the aqueous silver nitrate solution, which will be acting as your electrolyte inside which these two rods are being dipped. Okay. Now you have to plan out the experiment that what you are doing. So first of all, in the first step, what we have done, first of all, we have taken the metal spoon. So take a metal spoon, clean it, and connect it with the negative terminal of the battery, negative terminal of battery. Okay, so that it can act as a cathode. Secondly, what you will do, you will be taking a silver rod, take a silver rod and connect it with positive terminal of battery, positive terminal of battery, which will be acting as a anode. Okay, so you over here you can write in the bracket also that it is a cathode and it is a anode. Okay, now after making that connections, what you have to do, you have to dip those anode and cathode inside the electrolyte solution. Okay, so first of all you have to prepare that electrolyte solution. Why? Because the silver nitrate was given in the solid form and you were having the distilled water. Okay. So what you will do, you will dissolve the solid silver nitrate AgNO3 in distilled water in a beaker to prepare an electrolyte. Okay. So after preparing an electrolyte, now what you will do, you will uh, dip the anode and cathode into the electrolyte electrolyte and uh, start uh, turn on the battery. Okay, so that the current is start passing. Okay, and turn on the battery. So as soon as you will turn on the battery, what will happen? The electroplating will start. Okay, so you have to give it a certain time, and after a certain time, what you will do? You will stop passing the current. You will stop the battery. Okay, so what we will do? Okay, uh, passing stop passing the current uh, after certain time interval and take out the spoon. Okay, so when you will take out the spoon, what you will do, you will clean it with the help of the filter paper. Clean the spoon uh, with filter paper filter paper and dry it. Okay, and after drying it, so the now the electroplating has been done. But one question they were asking in the question that okay, uh, how would you determine the mass of the silver electroplated on the spoon? So you have to determine that what mass of silver has been deposited. So for that, what you have to do, you have to write down the formula that mass of silver deposited. So how you gonna know that how much mass of silver has been deposited? So for that, what you have to do, first of all, you have to take the initial mass of the spoon. Okay. So whatever is the initial mass of the spoon, you have to record that value before starting this process of electroplating. And then after completing the process of electroplating, when the silver will be deposited on the spoon, so you have to take the final mass of the spoon also. So final mass minus initial mass. When you subtract the initial mass from the final mass of the spoon, so you will get the mass of the silver which is being deposited. So what you have to do, you have to subtract the final mass of the spoon from the initial mass of the spoon. So in this way you will get to know that how much uh, silver has been deposited during this experiment. Okay. So this was a 6 mark question. So you have to completely mention each and every step along with this final formula. So in this way you will take 6 out of 6 marks in this question. So I hope that everything is clear to you. And this was the complete paper of Feb March 2025. Meet you in the next video with some other past paper. Thank you for watching the video. Take care and Allah Hafiz.